Welcome to the Deep Dive. Our mission here is to distill the most complex source material into key knowledge and profound insights for you.
And today, well, we're tackling maybe the biggest mystery of them all.
Absolutely. We're diving into consciousness.
It's the strangest thing, isn't it? It's the most obvious fact of our lives that we are experiencing things right now.
Right, you feel the world, you hear my voice.
Exactly. But try to pin it down scientifically. Try to measure that subjective feeling. It vanishes. It's completely invisible to our objective tools.
For thousands of years, people have wrestled with this. How does this inner world, this subjective experience, fit into a universe that seems fundamentally physical?
It's a huge question. So today we're going on a deep dive through modern consciousness studies. We'll look at the core concepts, the big theories, the really mind-bending experiments that define this field.
We're navigating that huge gap. Someone called it a yawning chasm.
Right.
Between the private mental life we all have.
And the physical stuff happening in our brains.
Yeah.
The neurons firing, the chemicals flowing.
And we have to start right there with the absolute core challenge. How does that physical activity, billions of brain cells doing their electrochemical dance, how does that become your private subjective experience?
The redness of that sunset you remember, or the sharp sting of a paper cut, or just the feeling of being you.
How does the physical generate the phenomenal?
Like cap. That's what the philosopher David Chalmers really nailed down when he called it the hard problem of consciousness.
Chalmers making that distinction was really key, wasn't it? Because it forced people to separate it from what he called the easy problem.
Right, and easy is definitely relative here. We're talking about incredibly complex scientific questions, like how does memory work? Or how did the brain process vision? Or how do we focus attention?
Still huge challenges for neuroscience.
Monumental challenges. But they're problems of function. We could see, at least in principle, how we might tackle them using the standard methods of science. Find the mechanism, map the process. Chalmers' point was that even if we completely solved all of those functional problems, understood every mechanism for learning, attention, behavior, we'd still be absolutely no closer to solving the hard problem.
Why not? If you know how everything works.
Because the hard problem isn't about what consciousness does. It's about what it is, what it feels like to be conscious.
Ah, the experience itself.
The subjective quality, the phenomenal feel. Until science can explain why that specific pattern of neural firing feels like anything at all, let alone like seeing red or feeling sad, we haven't touched the core mystery. It's like you could explain exactly how a TV works, every circuit, every pixel.
Yeah.
But that doesn't explain the feeling you get watching a really powerful movie on it. That subjective impact, that's the hard problem.
Okay, let's try to unpack this chasm. The most intuitive way people have thought about it historically is just to say mind and body are fundamentally different things.
Right, dualism. The idea that there are two distinct kinds of reality.
And this idea is everywhere, isn't it?
Oh, absolutely. It's deeply embedded in most major religions, the idea of a soul, an Atman, something non-physical that survives death. You see it in New Age beliefs, mind over matter. It resonates with our intuition that thoughts and feelings aren't quite like rocks or chairs.
And René Descartes, back in the 17th century, he really formalized this.
He did. Cartesian dualism, he laid it out very clearly. You have two fundamental substances.
There's the physical world.
Res extensa, extended substance. It takes up space, it has mass, it follows mechanical laws. Your body is part of this.
And then there's the mind.
Res cogitans, thinking substance. Non-physical, doesn't take up space. Its essence is thought, awareness, consciousness itself.
Which sounds neat. It explains why mind feels so different from matter. But
it crashes immediately into the interaction problem. If mind and body are totally separate realms made of different stuff, how do they interact?
How does my non-physical decision to lift my arm actually make my physical arm move?
Exactly. How does an unextended thought exert force on extended matter? And how does physical damage to the body cause non-physical pain in the mind?
What was Descartes' answer? Didn't he suggest the pineal gland?
He did, yeah. He picked the pineal gland because it seemed unique, sort of central in the brain. He thought maybe that was the bridge.
But that doesn't really work, does it?
Not really. Critics jumped on it immediately. The pineal gland is still physical. It's made of matter, takes up space.
So it's part of the res extensa.
Right. So how does this physical thing talk to the non-physical mind without violating the very division Descartes set up? It doesn't solve the problem. It just relocates it to this tiny gland. You'd need some kind of constant miracle or a violation of physics for it to work.
And that interaction problem is still the major hurdle for any kind of dualism today.
It really is. Which is why most scientists and philosophers lean towards materialist monism.
Meaning?
Yeah.
Only one kind of stuff.
Only one fundamental kind of stuff exists, and that's physical matter or energy. Everything else, including mind and consciousness, must somehow arise from or be identical to physical processes.
But then, boom, we're right back at the hard problem. How does matter become experience?
Precisely. And this brings us to the specific term philosophers use for those subjective qualities of experience. Qualia.
Qualia, like the redness of red, the specific feeling of warmth.
The taste of chocolate, the sound of a trumpet, the feeling of envy. These are the raw feels, the subjective textures of experience.
And they have these characteristics, right? They're hard to describe.
Yeah, they're often called ineffable. How do you describe red to someone who's never seen it? You can only use analogies. They're private. I can't directly experience your qualia. You can't experience mine.
And they seem immediate. The feeling is the experience.
It is. Qualia point to the absolute core of consciousness, subjectivity, what it's like to be something.
Which leads us to Thomas Nagel's famous question from the 70s.
What is it like to be a bat?
Such a great way to put it.
Isn't it? Nagel wasn't asking about bat behavior or sonar mechanics. We can study those objectively.
Right.
He was pointing out that a bat experiences the world through echolocation. It has a phenomenal reality, a set of qualia associated with navigating by sound that is utterly alien to us. We could know everything physical about the bat's brain.
And still not know what it feels like to be that bat.
Exactly. And that led Nagel to suggest maybe the problem is just too hard for our kind of minds. Maybe we're cognitively closed to the answer, as Colin McGinn later argued. Our brains just didn't evolve to grasp this.
Wow. Okay, so if subjectivity is the key issue, then the thought experiment that really forces you to take a stand is the philosophical zombie.
This is the big one, the pea zombie. Imagine a creature, or maybe even a perfect replica of you.
Okay.
Molecule for molecule identical. It walks, talks, laughs at jokes, writes poetry, cries at sad movies, screams if you stick it with a pin. It does everything a conscious person does.
Functionally identical.
Perfectly identical in every measurable way. But there's one crucial difference.
What's that?
It has no inner life, no subjective experience, no qualia. It's all dark inside. There's nothing it is like to be the zombie.
Right. The lights are on, but nobody's home, phenomenally speaking.
Exactly.
Yeah.
Now, the question isn't, are there zombies walking among us?
No, probably not.
The question is such a creature even conceivable? Is it logically possible, even if it doesn't exist in our world?
And why does that matter?
Because if a pea zombie is conceivable, if you can imagine all that complex physical functioning happening without any accompanying inner experience,
then consciousness must be something extra, something added on top of the physical machinery.
Precisely. That's the view Chalmers champions. If zombies are possible, consciousness isn't automatically produced by complex computation. It's an extra ingredient. And then you have a really hard time explaining, well, what's it for? Why did it evolve if the zombie does just fine without it? It validates the hard problem as a genuinely distinct problem.
But what if you think the whole idea of a pea zombie is just absurd? Impossible even in principle?
Then you're likely in the other camp, with thinkers like Daniel Dennett or Patricia Churchland. They argue that the concept is incoherent.
How so?
They'd say that any system complex enough to do all the things a human does perceive nuance, react appropriately, report internal states, learn, adapt, must, by definition, be conscious. For them, consciousness isn't an extra ingredient. It's what that kind of sophisticated processing is. It's intrinsic to the function.
So functionalism. If it walks like a duck and quacks like a duck and processes information like a conscious duck,
then it is a conscious duck. From this perspective, the hard problem is based on a faulty intuition, a failure of imagination. You can't subtract the qualia without crippling the function.
So it's a fundamental fork in the road. Either consciousness is this mysterious extra property hovering above the physical,
or it's simply what certain complex physical systems do, or what it's like to be those systems. And this split really shapes how neuroscientists approach the brain.
Okay, let's shift focus a bit to the brain itself. Because the structure of the brain seems, well, almost contradictory to how our consciousness feels.
What do you mean?
Well, my experience right now feels unified. It feels like one single stream, one me experiencing everything together.
Right, there's a sense of wholeness.
But the brain, anatomically isn't like that at all.
Not in the slightest. The brain is a massively parallel and distributed system. Billions of neurons clustered in specialized areas, all processing different kinds of information simultaneously. There's no central hub, no single processor where everything comes together.
It's more like a vast network, or maybe the internet?
Oh.
Lots of nodes doing their own thing.
That's a decent analogy. Information is processed all over the place, often redundantly with lots of crosstalk, but no single command center.
And yet subjectively, we experience these profound unities. You mentioned 3 key ones in the source material.
Yes. The unity of contents right now, the sight of the room, the sound of my voice, the feeling of the chair, it all seems bound together into one present moment. Then the unity over time. My sense that the me of 5 minutes ago is continuous with the me now, and will be continuous with the me tomorrow. A flowing stream.
And the third?
The unity of self. The feeling that there is a single subject, an I, who is the owner or experiencer of all these unified contents across time.
Right, the sense that I am the one having the experience.
And it's this deep-seated intuition of a central I watching the show that Daniel Dennett targeted with his critique of the Cartesian theater.
The Cartesian theater, so named after Descartes.
Exactly. Dennett argues that even people who claim to be materialists often fall back into a kind of dualist thinking without realizing it. They imagine that somewhere in the brain, all the sensory information gets processed, integrated, and finally presented on some kind of inner stage.
Where the conscious self, the me, sits in the audience and watches it. The movie in the head idea.
Precisely. We feel like we're a little person inside our skull, looking out through our eyes. Dennett says this is a disastrously misleading metaphor.
Why? What's wrong with it?
Because neuroscience shows there is no such place in the brain. There's no finish line where information crosses over and magically becomes conscious. There's no central stage, and certainly no little person in the audience.
So believing in the theater, even implicitly, means you're still stuck with a mini version of the interaction problem. How does the stuff on stage get perceived by the audience?
You got it. It smuggles in a homunculus, a little man, and doesn't explain consciousness at all. It just pushes it back. Dennett proposes instead a multiple drafts model. Consciousness isn't one final show, but rather a collection of ongoing parallel processing streams, edited and revised, none of which is the official conscious version until maybe you probe it by asking a question.
Okay, so if there's no central theater, no single place where consciousness happens, then the scientific goal shifts, right? It becomes about finding the neural correlates of consciousness, the NCCs.
That's the main experimental program. Let's find the specific brain activity that is reliably associated with specific conscious experiences. What patterns of firing correspond to seeing red versus not seeing red, or feeling pain versus not feeling pain?
Pain seems like a really good example here. It's so vivid, so undeniably subjective.
It is, and we actually know a lot about the objective pathway.
Right, you stub your toe.
Nerve endings fire. Signals travel up specific pathways, like the C fibers, through the spinal cord up to the thalamus, and then activate various areas in the cortex, especially the somatosensory cortex, which maps the body, and the anterior cingulate cortex, which seems related to the unpleasantness, the emotional aspect of pain.
And we can see this in brain scans. The activity goes up when people report more pain.
Exactly. There's a very strong correlation between the level of activity in these NCCs and the subjective report of pain intensity.
And here's the big but again. Correlation isn't causation, and it definitely isn't identity.
That's the wall. We see that brain activity A happens when subjective experience B happens. But does A cause B? Are A and B actually the same thing described differently? Or is there some hidden factor, C, causing both? The correlation itself doesn't tell us.
It doesn't explain why that specific firing pattern in the cingulate cortex should feel like horrible, agonizing pain, rather than, say, like tickling or like nothing at all.
Exactly. The explanatory gap remains. We've found the shadow of consciousness in the brain, but we haven't found consciousness itself or explained how the shadow is cast. The magic difference between correlated neural activity and raw subjective feel is still a mystery.
And this comes up really clearly in experiments with things like ambiguous visual figures.
Oh yeah, like the Necker cube, that line drawing of a cube that seems to flip orientation.
Yeah.
Or binocular rivalry, where
Yeah.
you show different images to each eye and your perception flips back and forth between them. These are brilliant tools for NCC research, because the physical stimulus hitting your eyes stays the same. The only thing changing is your subjective experience, which way the cube looks, which image you're seeing.
So you can look for brain activity that changes precisely when the experience changes.
Exactly. And researchers like Nikos Logothetis did this with monkeys, trained to report which image they were seeing during binocular rivalry.
What did they find?
They found that activity in the very early visual processing areas like V1, which gets the raw input from the eyes, didn't really change much. It reflected the constant physical stimulus.
Okay.
But activity in higher visual areas like V4 and parts of the temporal cortex, which are involved in object recognition and interpretation, that activity flipped perfectly in sync with the monkey's reported perception.
So maybe V4 is where visual consciousness happens? Those are the consciousness neurons?
It's incredibly tempting to say that. And V4 is certainly a strong candidate for an NCC for visual awareness. But we're still stuck with the same philosophical problem.
We still don't know why.
We still don't know why that pattern of firing in V4 neurons generates the experience of seeing, say, a house, while the equally complex firing in V1 neurons apparently doesn't or contributes in a way we're not conscious of, as Francis Crick put it. We've correlated the flip in experience with a flip in brain activity, but the nature of that link, the magic, is still elusive.
Okay, so the idea of a unified self and a central theater seems shaky. Let's dig into another pillar of our subjective experience. The feeling that I am in charge, that I consciously decide to do things, my free will.
Ah, yes, conscious will. And this is where the experiments by Benjamin Libet in the 1980s dropped a bombshell. He found what's often called a half-second lag.
This is the one about deciding to move your finger.
Exactly. Libet wanted to carefully time the sequence of events when someone makes a simple, spontaneous, voluntary action, like flexing their wrist. He measured 3 things.
Okay, what were they?
First, M and watched the exact moment the muscle actually moved, measured in the electrodes on the wrist. Easy enough.
Got it.
Second, RP, the readiness potential. This is a buildup of electrical activity in the brain, specifically the motor cortex, that precedes a voluntary movement. You can measure it with EEG scalp electrodes. It signals the brain is preparing to act.
Okay, brain prep.
Third, and this was the tricky one, W2, the moment the person felt the conscious intention, urge, or decision to move, the subjective now moment.
How on earth did he measure that? You can't stick an electrode on a feeling.
Used a clever clock. Subjects watch a special fast-moving clock face, like a spot sweeping around a dial. When they felt the urge to flex their wrist, they had to note the position of the spot on the clock at that instant.
Ah, okay, so they report the time of their conscious decision.
Yes. And Libet compared the timing of these 3 events: M, movement, RP, brain prep, and W, conscious will.
And the results were surprising.
Astonishing, really. The readiness potential, the RP, the brain activity preparing a movement, started about 550 milliseconds. It's over half a second before the actual muscle movement.
Wow. Okay. The brain gets ready quite early.
But here's the kicker. The conscious awareness of wanting to move, the W moment, only occurred about 200 milliseconds before the movement.
Hey, wait. So the brain starts preparing the action. Then about 350 milliseconds later, you feel like you decide. And then the action happens.
That's exactly what Libet found. The brain activity initiating the action begins significantly before the subjective feeling of having decided to act.
So, my conscious decision didn't actually cause the action, it came too late.
That's a straightforward and quite radical interpretation. Consciousness seems to be informed after the brain has already set the wheels in motion. The feeling of consciously willing the act might be more like a commentary or an after-the-fact awareness, rather than the actual driver.
That really undermines the whole idea of free will as we normally think about it.
It certainly challenges it profoundly. It suggests that the initiation of our voluntary actions might be fundamentally unconscious.
Did Libet himself accept that? It seems pretty bleak.
He was uncomfortable with it. He tried to salvage a role for consciousness by proposing the conscious veto.
Free won't instead of free will.
Kind of, yeah. He noticed in some trials the RP would start to build up, but then the subject wouldn't actually move. And around that 200 millisecond mark before the potential movement, the RP would flatten out. He suggested that while consciousness might not initiate the urge, it might still have a window of opportunity in those last couple hundred milliseconds to block it, to veto the action.
So we can't start things, but we can stop them. We're responsible for what we don't inhibit.
That was Libet's attempt to preserve some moral responsibility. Consciousness as a gatekeeper, not an originator.
But there have been criticisms of the whole experiment, right? Especially about measuring W, that moment of willing.
Oh, big time. Philosophers and neuroscientists jumped on that. Does it even make sense to put a precise timestamp on a subjective feeling like wanting to move?
What's the argument against it?
The main critique is that The very act of monitoring your intention and relating it to an external clock might distort the experience itself. And more fundamentally, it still seems to rely on that Cartesian theater idea, that there's a specific point in time when an intention enters the conscious spotlight.
Back to Dennett's critique.
Exactly. If consciousness is more like multiple drafts, maybe W is just the moment the system constructs a retrospective story about having decided make the timing relative to the brain's actual initiation process misleading. Measuring W might be measuring an artifact of introspection.
And there's other evidence suggesting our conscious experience of time isn't always accurate, that the brain plays tricks with sequencing.
Absolutely. Our subjective timeline isn't a perfect recording. Think about the chiming clock example.
Okay.
You're deep in a book, the grandfather clock starts chiming in the hall. You don't really notice the first couple of chimes. Then maybe on the third or fourth dong, you become aware, oh, the clock is striking. But often, in that moment of awareness, you can somehow recall the first two dongs you weren't paying attention to. They feel like part of the recent conscious experience.
So were they conscious when they happened? Or did the brain kind of pull them into consciousness retroactively when I started paying attention?
It's a paradox if you insist consciousness is strictly in or out at each moment. It seems more likely the brain registered the sounds unconsciously, and then when attention was caught, it bundled the recent sensory data together into a coherent, seemingly continuous conscious event. It constructed the stream after the fact.
Wow. Okay, that's subtle. Is there a more sort of physical demonstration of this time bending?
The cutaneous rabbit is amazing for this.
The what?
Cutaneous rabbit. Imagine someone taps you quickly, say twice on your wrist, then twice near your elbow, then twice up on your shoulder. Blindfolded, perhaps.
Okay, 6 taps in 3 locations.
Right. But what people often report feeling isn't distinct groups of taps. They feel a sensation like something is hopping or scampering smoothly up their arm from wrist to elbow to shoulder.
Whoa. How does that happen? The taps are in separate places.
The brain apparently takes the later information, the taps on the shoulder, and uses it to fill in the gaps and reinterpret the earlier taps. It creates a more plausible narrative of continuous motion after all the taps have occurred. It delays and spatially repositions the earlier sensations to make a smooth rabbit jump up the arm.
So my conscious experience of the first tap isn't even fully formed until after the later taps have happened and been processed.
It seems that way. The brain is clearly constructing the subjective timeline, and it's not always in sync with the objective order of events. It's editing the story for coherence.
Okay, if our timing is reconstructed, and Libet's work suggests our conscious decision comes late, then this leads to Daniel Wegner's idea about the illusion of conscious will, doesn't it?
It fits very well. Wegner argued that our feeling of, I did that, our sense of agency, isn't a direct perception of causing the action. It's more like an inference the brain makes.
An inference based on what?
He proposed that usually 2 things happen roughly simultaneously, both generated by unconscious brain processes.
Right.
1, the brain initiates the physical action. 2, the brain generates the thought about performing the action.
Okay.
Because the thought often precedes the action by a short interval, and the thought is consistent with the action, and there aren't other obvious causes, we jump to the conclusion. My thought caused my action. I willed it.
But really, both the thought and the action stemmed from a deeper, unconscious source.
That's Wegner's theory. Conscious will is the feeling that arises from attributing the action to our thought, but it's an attribution, a kind of illusion of causality, not the actual cause itself.
Are there examples where this connection breaks down? Where we do something but don't feel we willed it?
Absolutely. Think about table tipping during 19th century seances.
Mm-hmm.
People genuinely believed spirits were moving the heavy table. Michael Faraday investigated this scientifically. He showed that the table was actually being moved by tiny, unconscious muscle contractions, ideomotor actions, from the sitters themselves. They were causing the action, but because it didn't follow the usual, I intend to move the table thought-action pattern, they experienced no sense of willing it. They attributed it to an external force.
So the feeling of will was absent, even though they were the agents.
Exactly. And Wegner showed the opposite can happen too. You can feel you willed something even when you didn't do it.
How did he show that?
He used a setup where a subject and a confederate who was in on the experiment both had their hands on a computer mouse that moved a cursor over pictures. The subject heard instructions and words through headphones. Sometimes the confederate would secretly force the mouse to stop on a particular picture.
Okay.
If the subject happened to hear the name of that picture through the headphones just before the mouse stopped, they reported a significantly stronger feeling that they had intentionally stopped the mouse there, even though they hadn't.
Wow. So the thought, duck, arriving just before the action, stopping on the duck, created the feeling of agency, even if the action was caused by someone else.
Precisely. It shows how easily the feeling of will can be generated or manipulated based on cues of timing and consistency, separate from the actual causal chain.
And this framework helps understand conditions like schizophrenia, perhaps, where people might feel their thoughts or actions are being controlled by external forces.
It does offer a potential insight. Perhaps in some conditions, the brain's mechanism for correctly attributing actions to the self breaks down. The actions still happen, the thoughts might be there, but the normal feeling of I am the author of this is lost or distorted. It really highlights that our everyday sense of being a unified, controlling self is a complex cognitive achievement, not a simple given.
Okay, so conscious will seems illusory. Time perception is tricky. This really starts to chip away at the idea of a solid, enduring self. And maybe the most dramatic evidence against a single unified self comes from split-brain patients.
These cases are absolutely fascinating and deeply informative. These were patients, usually with severe epilepsy, who had the corpus callosum surgically severed.
That's the main bundle of nerves connecting the left and right brain hemispheres.
Exactly, a massive pathway. Cutting it stops seizures from spreading across the whole brain. And remarkably, in everyday life, these patients seemed pretty normal. They could talk, walk, function.
But under specific testing conditions.
A completely different picture emerged. You could essentially communicate with each hemisphere separately, revealing two potentially independent streams of awareness within one skull.
How did they test that? It relies on how vision and motor control are wired up, right?
Yes. Information from the right visual field goes primarily to the left hemisphere, and the left hand is controlled by the right hemisphere, and vice versa. And crucially, in most people, language processing is heavily localized in the left hemisphere.
The speaking hemisphere.
Right. So if you quickly flash the word kiwai to the patient's right visual field,
It goes to the left, speaking hemisphere.
and the patient could say, I saw ki. Easy. But if you flashed ki to their left visual field,
It goes to the silent, non-verbal right hemisphere.
the patient would verbally report, I didn't see anything. Because the left hemisphere, which speaks, genuinely didn't see it.
But did the right hemisphere see it?
Yes.
Yes.
Because if you then ask the patient to reach under a screen with their left hand, controlled by the right hemisphere, and pick out the object they saw from a group of items.
The left hand would correctly pick up the key.
Exactly. The right hemisphere saw the word, understood it, and directed the left hand, all without the conscious awareness of the speaking left hemisphere.
That's incredible. Two separate spheres of knowledge in one head.
It gets even stranger. This leads to confabulation, where the speaking left hemisphere basically makes up stories to explain actions initiated by the right hemisphere, trying to maintain the illusion of a single coherent self.
You mean the famous Gazzaniga experiment with the pictures?
That's the classic one. P.S. was the patient. His right hemisphere, via the left visual field, was shown a picture of a snowy winter scene. His left hemisphere, via the right visual field, was shown a picture of a chicken claw.
Okay, different pictures to each side.
Then he was asked to point with each hand to a related picture from a set of options. His right hand, controlled by the left chicken claw hemisphere, correctly pointed to a picture of a chicken.
Makes sense.
His left hand, controlled by the right snow scene hemisphere, correctly pointed to a picture of a shovel. Also makes sense for clearing snow.
Right, each hemisphere responded logically to what it saw.
Yes. But then the experimenter asked PS, meaning asked his speaking left hemisphere, why did you point to the shovel? Now, the left hemisphere had no access to the snow scene information that prompted that choice.
So what did it say? Did it say, I don't know?
Nope. It instantly confabulated, created a plausible-sounding reason that integrated both choices into one narrative. PS said something like, oh, that's easy. The chicken claw goes with the chicken, and you need a shovel to clean out the chicken shed.
Wow. It just made up a story to connect the unrelated actions.
Exactly. The left hemisphere acts like an interpreter module, constantly trying to make sense of our behavior and maintain a coherent story of me, even if it has to invent reasons when it lacks information. It prioritizes narrative unity over accuracy.
This really seems to support ideas like Derek Parfit's bundle theory of the self.
It does. Parfit argued there is no single enduring self or subject that persists through time. Instead, we're just a collection, a bundle of different perceptions, thoughts, memories, and intentions, loosely held together by psychological continuity.
So in the split brain patient, the bundle is just looser, partially divided.
You could see it that way.
Yeah.
If there's no essential I to begin with, then the puzzle of whether the split brain patient has one consciousness or two kind of dissolves. They're just experiences, sometimes linked, sometimes separate. There's no single owner being divided.
Okay, another major illusion seems to be in vision. We feel like we see the world in rich photographic detail all the time. A continuous movie.
That's the intuitive feeling, the grand illusion of vision. But cognitive science shows this is profoundly wrong.
How so? What's the evidence?
Well, for starters, think about your blind spot. Each eye has a large area on the retina where the optic nerve exits, and there are no photoreceptors there. It's a big hole in your visual field.
I don't see a hole. The world looks complete.
Exactly. The brain fills it in. But how? Does it paint in the missing details, like Photoshop? Then it argues it's more like conceptual filling in. The brain basically makes an assumption. Nothing new or important is happening in that blind spot region, and the surrounding area is, say, blue wallpaper, so I'll just operate as if it's all blue wallpaper. It doesn't create a picture, it just ignores the lack of data unless something contradictory happens.
Okay, so it's an assumption, not a rendering.
And this lack of detailed internal representation is dramatically shown by change blindness.
This is where huge changes happen in a scene, and people just miss them.
Completely miss them. If a change happens during an eye movement, a saccade or a blink or a brief flicker on a screen, like in those spot the temp games, people can fail to notice really obvious things changing. Colors, objects appearing or disappearing, even the person they're talking to being swapped out.
The door study is the famous one, right? Where someone asks for directions and movers carry a door between them and the person asking directions is swapped.
Yes. And a surprising number of people just carry on the conversation, completely oblivious that they're now talking to a different person.
What does this imply about our visual experience?
It implies that the feeling of seeing a rich, detailed world all at once is the illusion. We don't have a detailed internal snapshot. According to researchers like Ronald Renzink, what we likely do is build detailed representations only of the object or area we are currently paying attention to.
So we just have a spotlight of detail and the rest is kind of blurry or schematic.
Essentially, yes. We feel like we see the whole room in detail because we know we can shift our attention anywhere, anytime, and instantly get the detail from the world itself. The world acts as its own external memory, its own best model. We don't need to replicate it all inside our heads.
The richness is potentially available out there, not actually represented in here.
That's a great way to put it. And this leads to an even more radical view. The sensorimotor theory of vision, proposed by Kevin O'Regan and Alpha Noe.
What do they argue?
They take it a step further. They say seeing isn't about building any kind of internal representation, detailed or schematic. Seeing is a way of acting. It's about knowing how sensory input changes as you move.
Knowing how things look different if I tilt my head or move closer.
Exactly. Seeing red isn't having an internal redness quail. It's implicitly understanding the whole set of rules, the sensoromotor contingencies, governing how the sensory input related to that red surface will change with your eye movements, head movements, changes in lighting, etc.
So perception is a skill, a kind of bodily knowledge about how to interact with the world.
That's the core idea. Vision is exploration, it's active. If you accept this, the problem of how the brain creates the internal picture disappears because you deny the premise that an internal picture is created at all. The grand illusion is dissolved.
Okay, we've seen challenges to the unified self, to conscious will, to the richness of vision. This brings us back full circle to the hard problem and evolution. If consciousness, especially qualia, is real but maybe doesn't do much functionally, why did it evolve?
That's the million-dollar question, maybe the billion-dollar question. We circle back to the P-zombie dilemma.
Right. If a zombie can do everything I can do behaviorally without any inner experience,
then natural selection would have no reason to favor conscious beings, Conti's over zombies. The extra subjective feeling would be like a useless decorative frill. It wouldn't improve survival or reproduction.
So if consciousness did evolve, it must have some function, some adaptive advantage.
That's the standard evolutionary assumption.
Yeah.
And people have proposed functions. Nicholas Humphrey, for instance, suggested consciousness evolved as a tool for social intelligence.
How would that work?
His idea was that by developing an inner eye to observe our own mental states, our thoughts, desires, intentions, we gained a powerful model for understanding and predicting the behavior of others. We simulate their minds using our own as a template.
That makes sense. Understanding others is crucial for social animals.
It is. But the problem, again, is, does this explain the subjectivity, the raw feel, the qualia? Why couldn't a highly sophisticated non-conscious zombie run an equally effective simulation of self-states and other states purely functionally, without any inner light show?
It seems like we're still left with that core mystery of the feeling itself.
We are. Which leads some thinkers, perhaps most notably Susan Blackmore, drawing on Dennett and others, to propose the most radical conclusion of all. Maybe consciousness itself, as we typically conceive it, is a grand delusion.
A delusion. How can the most obvious thing in the world be a delusion?
Well, the argument is that our belief in a continuous, rich, unified stream of consciousness experienced by an enduring self might be the illusion, generated by the brain's complex workings, but not actually corresponding to the underlying reality.
Okay, unpack that. What are the core assumptions we make that might be wrong?
Blackmore highlights two big ones we've touched on. One, that experiences are happening to someone, to a continuous self.
Which the split brain and bundle theory challenge.
Right. And two, that experiences are flowing continuously like a stream.
Which the timing paradoxes and change blindness challenge.
Exactly. If both the experiencer and the continuous stream are constructions, not realities, then what's left of consciousness as we usually imagine it?
This sounds like the fridge light analogy.
That's a perfect analogy for why we believe we're continuously conscious. Why do you believe the light inside your fridge is always on?
Well, because every time I open the door to check, it is on.
Precisely. The act of checking, opening the door, causes the state you're checking for, the light being on. Blackmore argues introspection is like that. Every time you ask yourself, am I conscious now? The very act of asking, of directing attention inward,
creates a moment of conscious awareness.
It forces the system to briefly construct a representation of self in current content, and the answer is inevitably, yes, I am conscious. You can never catch yourself not being conscious by using introspection, just like you can't open the fridge fast enough to see the light off.
So the delusion is generalizing from these probed moments to assume it's always like that.
That seems to be the idea. The truth, according to this view, might be that in the moments between those introspective checks, there isn't a continuous stream or a stable self. The brain is just humming along, processing information massively in parallel, doing its thing.
Multiple drafts, no final show.
Right. And consciousness, that feeling of unified subjective awareness, isn't a constant state. It's a fleeting event, something the brain concocts retrospectively, on demand, when probed or when necessary for certain kinds of planning or reporting. It spins up a temporary self and a temporary world from recent memory and processing.
If this is true, it has huge implications for understanding human consciousness compared to animals.
It really does. This view suggests that the delusion of consciousness, this particular narrative structure of a continuous self having experiences, might be uniquely human, or at least require very sophisticated cognitive machinery, because it seems to depend on things like language to formulate the question, am I conscious? A strong self-concept, the ability for complex meta-representation, thinking about thinking.
So other animals might have subjective experiences, maybe temporary phenomenal worlds tied to their actions.
Like the bat navigating by sonar, perhaps. They master their sensor-motor loops, they build perceptual worlds. But they might not construct the overarching story of being a continuous self having those experiences. They don't get tangled up in the same kind of reflective narrative consciousness that leads to the hard problem for us.
They live the experience, but they don't necessarily build the illusion about the experience.
That could be one way to think about it. They aren't asking, what is it like to be me, in the same way we are.
So if this delusion thesis is right, the goal of consciousness science changes dramatically.
It does. We stop trying to solve the perhaps impossible, hard problem of how physical stuff magically creates subjective feels. Instead, we focus on the easier, but still very hard, problem of explaining the mechanisms by which the brain generates the convincing illusion or the complex representation of continuous, unified consciousness. How does the brain trick itself so effectively into believing in the inner show?
And it's fascinating how this scientific perspective starts to sound a bit like, well, like insights from some very old philosophical or contemplative traditions.
There's a remarkable convergence, isn't there? Particularly with non-dual traditions like Zen Buddhism or Advaita Vedanta.
What's the connection?
Well, a core aim of many meditation practices is precisely to deconstruct the illusion of the separate, enduring self, to see through the notion of being a single I who is the thinker of thoughts and the experiencer of sensations.
They try to get past the ego, the constructed self.
Exactly. And advanced practitioners often describe states where experience simply happens, thoughts arise, sensations occur, but without the feeling that there is a central me to whom they are happening. It's described as experiences occurring, but with no experiencer.
Which sounds strikingly similar to the scientific picture emerging from split brains, bundle theory, and the critique of the Cartesian theater.
It does. It's as if careful, sustained introspection through meditation can lead to a direct insight that mirrors what neuroscience is inferring from objective data, that the unified continuous self is a powerful, perhaps useful, but ultimately constructed fiction. The scientific story and the contemplative story, coming from very different directions, seem to be pointing towards a similar, rather startling view of our inner reality. #outro.
So we started this deep dive facing what seems like an unbridgeable gap, the hard problem of how physical brains create subjective experience.
And we've ended up questioning the very foundations of that experience. The journey has taken us through the failures of traditional dualism,
To the neuroscientific evidence chipping away at the intuitive pillars of our inner world. The central Cartesian theater, the feeling of conscious will, the unity and continuity of the self, even the richness of our visual perception.
We saw how the brain confabulates, reconstructs time, and operates largely unconsciously, generating a feeling of control and awareness that might be more of an after-the-fact narrative than a real-time driver.
And the most radical synthesis suggests that consciousness, as that continuous stream happening to an enduring me, might be the ultimate grand illusion, or perhaps delusion. A fleeting construction generated only when the system probes itself.
The brain is in the audience watching the show. The brain is the show, a massively parallel performance with no single spectator.
Which leaves us, and you, with a final thought to mull over. If the deepest insights from both modern neuroscience and ancient contemplative practice converge on this idea that true understanding comes from seeing through the illusion of the separate, enduring self.
What does that mean for you, moving through the world? What are the moral, the existential implications of realizing you might not be the audience in the theater of your mind, but rather simply the ongoing, complex, perhaps ultimately ownerless performance